So here are the steps, according to the AP book, to developing object-oriented programming and design. The first step is to identify the classes to be written. So we're looking at what classes do we think we need to write to make this program work. And we're going to break each one of these down specifically throughout the slideshow, PowerPoint, video, however you're watching this. Then you also have to identify the behaviors, which would be the methods for each class. So we can take a look at what each class is supposed to do, and there's some different things we can look at here to determine what the methods would be. We're going to determine the relationship between the classes, and I'll show you what is called a UML diagram there. Then you're going to write the interface and then implement the methods. Probably one of the most important ones in beginning a program is to identify the different classes you're going to need. And the way to do this is once you complete your project description, you can help this along by IDing all the objects by picking out the nouns in the program specifications. So the example used that I think is the easiest to follow is a bingo game. And the example for the bingo game would be some basic objects including the bingo card or the caller. We're going to have a collection of players. The controller will be the game master, so how the game is going. And then the display, of course, will be the different bingo cards and the balls. I would argue that the balls that the bingo is running from could also be considered object, but I think that's a result of the controller, which is the game master who is controlling what is happening during the game. So those were the basic nouns that they pulled out to determine what was the best way to approach the different classes, because the card will eventually talk to the game master to figure out, hey, do I have the correct number drawn? It's pretty abstract when you think about it, and just the different ways you can approach it. We'll have to, as a class, take a look at how the AP book wants us to approach this. The next thing we need to do is to identify the behaviors. And remember, the behaviors is looking for what we can make the methods. So it looks for verbs that help lead to the solution of the programming task. So if we take a look back at the bingo example, where we are using, such as the caller, well, what's the caller going to do? He's going to draw a ball, and he's going to check to see if anyone has hit bingo. So that would be an example of a basic object. The card will be what the user's using, and they have to be able to place chips or check to see if they won. That would be the verbs that they would have to work with. They're checking, they're playing the game, they're doing different things. It all comes back to looking at it from a microanalysis standpoint. The next part is we need to determine the relationship between the classes so that the program can run together. There are two types of relationships we're looking at. The first is the inheritance relationship, with looks for classes with common behaviors. And if they do have common behaviors that they kind of inherit and depend on each other for, then they have that inheritance relationship. Composite relationships, meanwhile, are defined by the has-a relationship. For example, the nurse has a uniform. Typically, if two classes have a composition relationship, it should be composition instead of composite. So we'll just switch that. Composition relationship. And one of them contains an instance variable whose type is in the other class. So, I'm sticking with that example. The nurse has a uniform. A bingo card has the same numbers that are in the ball rack for the ball. And with this comes what is known as a UML diagram. So an excellent way to keep track of relationships between classes is to show the inheritance hierarchy in your program with a UML diagram. UML stands for Unified Modeling Language. So this is a type of drawing, essentially, that does not exactly follow a flowchart, but is very popular in the programming world. This is a standard graphical scheme used by OOPs, object-oriented programmers. Although it is not part of the AP subset, on the AP exam you may be expected to interpret simple UML diagrams. So, simplified UML rules. Let's take a look at them, please. The first is to represent classes with rectangles. I gotta make sure I have enough room here to type. Gotta represent classes with rectangles. We use angle brackets with the word abstract or interface to indicate either an abstract class or interface. That seems kind of a duh. Show the relationship between classes with an open up arrow. So I'm going to build this for you in a moment and show you the examples. We could show the is-a relationship as well that involves an interface with an open dotted up arrow. And then the final one is show a has a relationship with a down arrow or sideways arrow. And that has a solid black line and it's closed. It's a closed arrow. So I'm going to show you this model here on the next slide. Here's the example right out of the AP book. So let's take a look at those 5 bullet points again. The first one was represent classes with rectangles. So we have 2, 4, 6, 7 classes in this program. And it's just a real simple player program. We're using angle brackets with the word abstract or interface to represent whether it's an abstract or interface. So we have the abstract of a player who has an influence on the board and the scorecard. They could be a good player, they could be a bad player. For a bad player, they need a tutor, apparently. So, well, anytime you're bad at something, you need some kind of tutor. So, the show is a relationship between classes with an open up arrow. So it's saying that both a bad player and a good player pull from the player abstract. And that's right, because they're both a player, it's just what type of player are they? Hopefully I'm a good player. Show the is a relationship that involves an interface with an open dotted up arrow. So both of these guys are a result of player, which then talks to the interface. So there's the open dotted up arrow. And then the show the has a relationship with a down arrow or sideways arrow that is closed. So the player has a board, has a scorecard, and if they're bad, then they have a tutor. So from this diagram, you can see at a glance that the good player and bad player are subclasses of the abstract class player, and that each player implements the comparable interface. Every player has a board and scorecard, while only the bad player has a tutor. Shame on him or her. For implementing classes, we are looking at how classes actually execute. So we have to look at one term I did not put on here called, come on, show up. There we go. Collaborators. And these are classes needed to implement particular methods. Classes needed to implement particular methods. So what this turns into is what's called bottom-up development. So you're building the real basic foundations first and then getting them all to work together. So an example would be to get a robot's arm to move by itself, or getting the bingo balls to draw out, and then getting the chips to be placed on the card, and then getting the two to work together. That'd be bottom-up development. And once each of the independent classes is working, classes that depend on one another are implemented and tested. So oftentimes this doesn't work together right away, so then that's where the testing really becomes important. Next part we're looking at is how the implementation of methods flows. And there's a few things we want to briefly look at. Helper methods, I'm actually starting at the bottom here, is performing the same task for multiple methods. So this would be like in a game where you check to see if you won. If you have multiple scenarios where you could win, you would have one method checking in each of those other methods how you won or if you won. And that is known as procedural abstraction, where it allows that helper method to work with many other methods. There's also information hiding, which again talks about that private variable that we worked with. And again, that's a great banking example. Stub methods is a dummy method that stands in for a method until the actual method has been written and tested. So when we were doing our zoo project with the abstracts, those were examples of stub methods because we just stuck them in there and say, hey, this is what this will do. And then the final piece here is what's known as an algorithm, which we have talked about a little bit, which is a universal description of how something should work. So just a real basic example from the book, and then going to proceed forward here. Creating a program must create a teacher's gradebook. Yeah. Program must create a teacher's gradebook. I have no clue why I had trouble saying that. The program should maintain a class list of students for any number of classes in the teacher schedule. The menu should be provided that allows the teacher to create a new class for the student, enter a set of scores for any class, correct any data that has been entered, display the record of any student, calculate the final average and grade, print a class list with or without grades, add a student, delete a student, or transfer a student, and save all the data to a file. So that's a basic algorithm on how a gradebook should work. It's very universal, doesn't have a lot of descriptions specifically to the gradebook, but it still describes what it should do.